Welcome to the third episode of our drone technology series. Today we're covering flight sensors and the vital roles of the gyroscope and IMU. It is amazing to watch a drone hover in place, as if locked by a magnet, or instantly regain balance in strong winds. How is this possible? The secret lies in the Inertial Measurement Unit, or IMU, a flight sensor system that detects orientation in real time and auto-corrects flight attitude. Today we'll examine how key drone sensors work in essential maintenance steps every pilot needs to know for safe flying. First, let's look at the types of sensors and their key functions. Drones assess their status in real time using multiple sensors. The gyroscope measures angular velocity to detect changes in direction. The accelerometer detects linear acceleration, vibrations, and movement. Combining the gyroscope and accelerometer creates the integrated sensor known as the IMU. Additionally, an electronic compass identifies heading in north, while a barometric pressure sensor measures altitude changes to maintain a set height in indoor or GPS-denied environments. Vision sensors estimate position using floor-inside visual patterns. Latest models like the DJI Avatar 2 or Inspire 3 feature high precision IMUs and multi-directional vision sensors for superior hovering stability. Second, let's discuss the role of the IMU, the heart of drone attitude control. The IMU detects real-time tilt along three axes: roll, pitch, and yaw. If sudden wind tilts the drone, the system automatically adjusts individual motor outputs to restore balance. This IMU technology makes stable hovering possible. It is a core motion-sensing technology used not only in drones, but also in aircraft, spacecraft, smartphones, and autonomous vehicles. Third, let's focus on the gyroscope, which detects rotation. A three-axis gyroscope measures angular velocity across X, Y, and Z, axes representing roll, pitch, and yaw. It constantly calculates how much and how fast the drone is rotating. For instance, if wind pushes the drone to the right, the gyro sensor detects the angle and speed, instantly boosting power to the left motors to rebalance the aircraft. Fourth, the accelerometer detects movement and tilt. It measures linear forces generated when the drone moves or shakes. Based on this data, the IMU accurately determines whether the drone is falling, drifting sideways, or climbing rapidly. Analyzing accelerometer data allows the flight controller to stabilize the motors, ensuring smooth aerial footage and high-resolution photos. Fifth, here are essential maintenance checks for safe operations. First, perform regular IMU calibration. If your drone is new, took a heavy impact, drifts to one side, or hovers unstable, calibrate the IMU via the app on a flat surface. Next, watch out for compass interference. Metal structures, iron frames, or strong electromagnetic fields distort compass sensors. Keep at least 3 meters away from RVs, metal towers, or iron chairs before takeoff. Taking off with compass errors can cause loss of orientation and serious flyaways. Also, check the barometer if altitude fluctuates unexpectedly. Extreme heat waves or blizzards alter atmospheric pressure, rapidly increasing the risk of barometer malfunction. Avoid flying in severe weather. International safety guidelines and local aviation regulations emphasize regular pre-flight checks to prevent sensor failures that could cause property damage or injury. Sixth, here is how GPS and internal sensors work together. Perfect flight relies on seamless sensor teamwork. GPS tracks overall coordinates, the IMU controls precise attitude, the compass maintains heading, and the barometer locks altitude. Integrating all sensor data within the flight controller enables steady hovering and accurate directional flight. In conclusion, drone flight is more than just spinning propellers. It relies on a sophisticated network of sensors detecting subtle tilts, vibrations, and heading changes every millisecond. As drone pilots, an unmanageable drone is far more dangerous than one that won't take off at all. Safe and enjoyable flying begins with understanding and regularly inspecting these sensors. In the next episode, we will explore how drones communicate with controllers, including transmission frequencies and signal protocols. If you enjoyed this video, please like, subscribe, and turn on notifications. See you on the next flight. Thank you.